We're going to continue on our second day working with infinity and the idea of working with limits with that. And I did notice in your notes that I made a mistake. So this is 1 to b now. So the second day. We're going to continue talking about infinitesimal numbers. All right, those ideas that you've got infinity, which is the largest number you can think of, and then we have the smallest number that you can think of. So that would be 0 plus or 0 minus is the smallest number. We'll talk about what to do with infinity when it shows up in both the numerator and the denominator and how that connects to asymptotes as well. So just to review, we have already talked about what to do with 0 over 0. That was in lesson 1.1. That is an indeterminate number. We dealt with that with factoring, with FOIL, common denominators, etc. Yesterday, we dealt with what to do when you have a number on the top and just 0 on the bottom. So that's different than 0 over 0. It's a number over 0. And so looking at it, dividing that on the left and the right by 0 minus and 0 plus. Today, we're going to talk about infinity and when that shows up in the numerator and denominator. So just some concepts of infinity. Infinity is not a real number, so it's not defined. So that's why we use a symbol to denote it. But you can, there are some things you can and can't do with infinity. You can add and subtract. So if you have infinity plus or minus any number, you'll still have infinity. All right, that means if you add to infinity, you still have infinity. If you subtract a number from 1,000, a million, if you subtract a Google from infinity, you will still have infinity left. You can add infinity together. Infinity plus infinity would be infinity. You cannot, so fake math is subtraction. You cannot subtract infinity from itself. All right, that is an undefined number, because who knows if you have enough of one infinity to cancel out the other. Normally, if we do 5 minus 5, they cancel out and make 0, or 100 minus 100, or 1,000,000 minus 1,000,000. But when you have infinity minus infinity, they don't necessarily cancel each other out. So this is another indeterminate form. Okay, it's one of those ones where the rules don't work. Can you multiply? For sure. You can take infinity and multiply it by a number and still have infinity. You can take infinity and multiply it by itself and still have infinity. But the fake math you cannot do is you cannot take infinity and multiply it by 0, because you have two conflicting rules here. One rule is anything times 0 will always be 0. The other rule is anything times infinity will always be infinity. Well, now you've got a problem because you have infinity times 0. So which rule is it? Is it the 0 rule? Is it the infinity rule? Well, it's indeterminate. You can't decide which rule takes over here. What about division? Yes, you can divide. Infinity divided by any k number will still be infinity. That's taking the largest number possible and dividing it by a number, and it will still be the largest number possible. When you take a number and divide it by infinity, so now you're taking a number and dividing it by the largest number possible. And we talked about, well, if you divide by the largest number possible, then you'll get the smallest number possible. So this will give you 0, either plus or minus. But can you divide infinity by itself? And that is another indeterminate form. Because again, what rule do you use? Do you use the fact that anything divided by itself is 1? Do you use the rule that infinity divided by anything should be infinity? Do you use the rule that anything divided by infinity is 0 plus or minus? Okay, you've got 3 conflicting rules here, and so that's why this is an indeterminate form. So these 3 forms are the 3 new indeterminate forms that we have in addition to 0 over 0. So here's the overall problems. When you divide by a small number, smaller number, you get a larger result. When you divide by a larger number, you get a smaller result. So what happens when you divide by infinity, which is the largest number? Then we should get 0, either plus or minus, which is the smallest result possible. Okay, that's what we're going to get. So, anything divided by itself, that rule is 1, except 0 over 0 or infinity over infinity. Okay, these two cases where anything divided by itself is 1, that rule does not apply to these two terms. So this is called, these are two of those indeterminate terms we were talking about. So we already know what to do with 0 over 0. We know that we can factor. We know that we could maybe FOIL. We know that we could try common denominators. We know that we could reduce. So those are three things to try when you get that indeterminate form. And so that's our job for today, is to figure out what do we do when we have infinity over infinity. So anytime that you see this, there's really only one option, which is kind of nice. You don't have to choose 4 different things. There's only one thing to try, and that is to divide all the terms by the highest value of x to a power. All right, so what that means is if you look at the problem and the highest is x squared, that's the biggest degree. Okay, maybe we should change the word. Instead of saying the highest value, we could say the highest degree. And if you see the highest degree is x squared, then you're going to divide all the terms, all the parts by x squared. If you see the highest value is x to the 5th, then you're going to divide each term by x to the 5th. So let me demonstrate that for you. Here's an example. If we take the limit of this problem as x approaches infinity of parentheses f of x, and we try and drop infinity into this problem. Infinity plus 1 over infinity. Well, infinity plus 1 is still infinity, because you can add any number to infinity and still get infinity. So we have the indeterminate form, infinity over infinity. So my job now is to go back and divide by the highest power of x. So I look at this question and it's x to the 1st. So I'm going to divide all the pieces, top and bottom, by x to the 1st. So that's going to look like this. X plus 1, I'm going to divide both of those by x to the 1st. And the denominator was x, I'm going to divide that by x to the 1st. Then we're going to simplify what we have. I haven't dropped a number in yet, so I can't drop the limit notation. X over x reduces to 1. 1 over x doesn't reduce. This x over x also reduces to 1. Now I'm going to try and drop 0 into this problem. Excuse me, drop infinity. I didn't write into this question. So once I drop infinity in, I can drop the limit notation. So I'm going to have 1 plus 1 over infinity divided by 1. Now, is it legal to have 1 over infinity? For sure. It's just not legal to have infinity over infinity, but this is totally fine. So 1 divided by the largest number possible should be the smallest number possible. And the smallest number possible is 0 plus over 1. So 1 plus 0 plus is 1 plus divided by 1, which is still going to be 1 plus. Because 1 plus divided by 1, anything divided by 1, is itself. It works for negative infinity also. We do the same thing. We'll divide everything by the highest power of x to the 1st, and we reduce. we're approaching negative infinity. I forgot my negative sign here. So I'll have 1 plus 1 over x over 1, and I'll drop negative infinity into this question. So 1 plus 1 over negative infinity over 1. Well, the rule still is if you divide by the largest number possible, the answer is the smallest number possible, which is 0 minus this time because we divided by negative infinity. So that would give me 1 minus, 1 plus 0 is 1 minus, divided by 1. So I get 1 minus. And all that came because we had an indeterminate form to begin with. So let's try that again. Let's try a similar question. All right, if I drop infinity into this f of x, I will get 1 minus 5 infinity over infinity. All right, well, the rules say that 5 times infinity is still infinity. Infinity times any number is still infinity. So 1 minus infinity. 1 minus infinity is negative infinity over infinity. That is an indeterminate form as well because it's a negative in front of infinity over infinity, and that is an indeterminate form. So we go back and we say, what's the highest power of x? And again, it's x to the first. So I go back to my limit notation, and now I'm going to divide each piece, each term, by x to the first. So that will give me 1 divided by x minus 5x divided by x over x divided by x equals the next limit notation of 1 over x minus 5 over 1. I reduced each place that I had x over x. Now I can drop infinity in and at the same time drop my limit notation. So 1 over infinity minus 5 over 1. Again, 1 over infinity is 1 divided by the largest number, which should give me the smallest number. So that's a 0 plus minus 5 over 1. That's negative 5 plus over 1, or negative 5 on the right side. You'll do the similar thing with negative infinity. Because the math is the same, I'm going to go to the second step and go to the 1 over x minus 5. So it's the second step of the problem. It's this part. Okay, I'm just to save time, I don't have to write that down again. So I'm dropping negative infinity in this time. So 1 over, negative infinity minus 5 over 1. And again, 1 over negative infinity is 0 minus 5. I'm not going to put over 1 anymore because the denominator of 1 is sort of irrelevant. So 0 minus 5 is negative 5 minus. So I got negative 5 plus and negative 5 minus for my two limits. So what does that mean when you get these answers? When we plug in numerically, we got infinity over infinity, which was indeterminate. When we did the algebra, okay, that's where we divided by the highest power, we get a value. All right, let's look back. We got negative 5 plus, negative 5 minus. We got positive 1 plus, positive 1 minus. We got a value. So graphically, that means this time now we have a horizontal asymptote. So yesterday we had vertical asymptotes. Today we have horizontal asymptotes. So that means that this problem has a horizontal asymptote at -5. And this one has a horizontal asymptote at +1. So that's our theorem for today. You will have a horizontal asymptote, y = b, along the function if, when you do all the work approaching infinity, you actually get a value. Or if you do the work approaching -infinity, you get the same value. Then you will have a horizontal asymptote. So any graph then would have a horizontal asymptote line through the number of value of b, whatever b turned out to be. So let's apply that. Does this problem have any horizontal asymptotes? Well, first you check by plugging in infinity. So I'm going to put infinity here, I'm going to put infinity here, I'm going to put infinity here, I'm going to put infinity here. Infinity squared is still infinity. 2 times that is still infinity. That gives me infinity. Minus infinity plus 3 all over. Infinity squared is infinity. Oh, you know what? There's a typo in this problem. I'm really sorry. Can you make that a positive sign? Okay, there we go. And then plus another infinity. So we end up with infinity plus 3 is still infinity, and then infinity in the bottom. So we have our indeterminate form. So we're going to come back, and now we're going to approach this algebraically. So let me look at what the highest power of this problem is. And the highest power is the degree of 2. So it's a highest power of square. So that means I want to divide all the terms by x squared, each term. And I reduce where I can. So I'm going to have the limit as x approaches infinity, big parentheses, of 2x squared divided by x squared will leave me with 2. It's a plus sign, right? We changed that. Plus 5x over x squared reduces to 5 over x. Plus 3, which doesn't reduce, so it's just 3 over x squared. And then the denominator will be 3 plus 1 over x. Now that I've done the algebra, I can drop infinity and drop my limit notation. So I'll have 2 plus 5 over positive infinity plus 3 over positive infinity squared over 3 plus 1 over positive infinity. Dividing by these large numbers creates small numbers. So I have 2 plus 0 plus another 0 plus over 3 plus 0 plus. So I end up with 2 plus over 3 plus. Or I could write that as 2/3 with a plus on both of them. So let's see what happens with the negative infinity. I'm going to kind of jump to just dropping negative infinity in. So it's really just going to this same step here, but using negative infinity instead. So that'll be 2 plus 5 over negative infinity plus 3 over negative infinity quantity squared, which we know will be positive, over 3 plus 1 over negative infinity. So that's going to give me 2 plus 0 minus, and then plus 0 plus, over 3 plus 0 minus. So my 0 minus and my 0 plus cancel each other out. And I'm left with 2 over 3 minus. Now overall, or 2 over 3 minus. So overall, I've got the number 2/3, which was my value for both of them. And so my horizontal asymptote, so this equation would have a horizontal asymptote along the line at y equals 2/3. So if you would draw this or look at a graph, you would see, if that was the number 1, you would see a horizontal asymptote scooting across at 2/3. Okay, that would be a boundary line for this equation. Finding an end behavior model. That language is the same as finding a horizontal asymptote. So AKA, also known as horizontal asymptote. So the math is exactly the same. So I don't want you to get thrown off when you're asked a question in a different way. The math is exactly the same. So if we want to find the limit as x approaches infinity. So if we drop infinity into this question, so infinity here, infinity here, infinity here, we would get 3 times infinity squared, which is infinity still, infinity over infinity cubed, which is still infinity. So it's all infinity over infinity. So it's an indeterminate form. So I want to divide by the highest power of x in this question. And looking at it, I happen to notice that the highest power of x this time is x to the 3rd. So that means I'm going to divide each term by x to the 3rd, not 2x to the 3rd, just x to the 3rd. So when you're doing plus and minus infinity, I would say, like, show your work good on one of them and then kind of borrow your work for the other. So 3x squared, that term divided by x cubed. And then x, that term divided by x cubed. And then the denominator, 2x cubed, that term divided by x cubed. Equals limit, and then my parentheses. Okay, let's reduce. X squared over x cubed doesn't fully reduce, but we're left with 3 over x. X over x cubed doesn't fully reduce, but we're left with 1 over x squared. And then x cubed over x cubed fully reduces, and we're left with 2. So now let's drop infinity into this question, and we'll drop our limit notation. So that will give me 3 over infinity plus 1 over infinity squared over 2. 3 over infinity is 0 plus. 1 over infinity squared is 1 divided by the largest number, so also 0 plus over 2. 0 plus over 2. Okay, now we have 0, but it's not in the denominator, it's in the numerator. And 0 in the numerator is fine. And that will give me 0 plus, because 0, as long as it's in the numerator and not in the denominator, 0 divided by something is 0. Now let's check the negative. So I'm going to borrow my work, and I'm just going to go to right here, and I'm going to drop in negative infinity instead. So that would be 3 over negative infinity plus 1 over negative infinity squared over 2. 3 over negative infinity is 0 minus, because I'm dividing by the negative, plus, now remember, negative infinity squared is a positive number, because a negative squared is negative times a negative is a positive. So this will be 0, but it will be 0 plus over 2. So 0 minus and 0 plus basically cancel each other out to be plain 0, and we have 0 over 2. And 0 in the numerator is fine. I get 0. Therefore, I've got a match here, and so I have a horizontal asymptote, or an end behavior model, which is the same thing. Y equals 0. So graphically, if you're visualizing that, you would have an asymptote right along the x-axis here. Okay. We're going to try this again. I'm just trying to show you one of everything so that when you see it on the homework, you're not surprised. So let's drop infinity into these. 5 times infinity to the 4th is infinity. Minus 2 times infinity is infinity. Over infinity cubed, that is indeterminate. So we're going to divide by the highest power. Looking at this question, the highest power is x to the 4th. So I am going to divide everything by x to the 4th. 5x to the 4th divided by x to the 4th minus 2x divided by x to the 4th over x cubed divided by x to the 4th. Okay, this one will fully reduce. So I'll get the limit as x approaches positive infinity of the number 5. X over x to the 4th doesn't fully reduce, but I'm left with 2 over x cubed. And x to the 3rd divided by x to the 4th doesn't fully reduce either, so I'm left with 1 over x. I'll drop infinity into this and drop my notation. 5 minus 2 over infinity cubed over 1 over infinity. That's 5 minus 0 plus over 0 plus. So that's 5 plus over 0 plus. Now I have 0 in the denominator. This goes back to yesterday. When you have 0 in the denominator, you're dividing by the smallest number possible, which will create the largest number possible, and the largest number possible is positive infinity. Again, with the negative, I'm going to borrow my work from this step here, because up until that, the steps are the same. I'll just replace it with negative infinity. So I'm going to have 5 minus 2 over negative infinity cubed over 1 over negative infinity. So that'll be 5 minus 0, and it's still a minus, because negative infinity cubed would have 3 negatives in it, over 0 minus. So that would be 5 minus over 0 minus. So again, we have a 0 in the denominator, and we're dividing by the smallest number possible, which will give me the largest number possible, but with a negative sign. Now what does this mean? Okay, well this is not a match. And so I do not have a horizontal asymptote here. And so this function would not have any horizontal line acting as a boundary. Okay, so in this example, we're going to put everything together that we've learned from last week and this week. There are 4 one-sided limits to consider in this equation. There is a limit approaching negative infinity and positive infinity on one side. There are also limits in the center of the equation, okay, where I've got x is less than 2, so I'll have 2 left, and I'll have 2 right. So I have those 2 limits to consider as well. So we're going to put all of this together to figure out our limits. When I'm using negative infinity, x approaching negative infinity, and when I am using 2 left, in both of these, I want this. Okay, when I'm using negative infinity and when I'm doing 2 left, they both are using the equation 1 over x minus 2, because both of those are in this category where the domain is less than 2. When I switch and I do 2 plus and infinity, which are both positive numbers, then both of these will be using this equation. So it's helpful in your parentheses, I think, to distinguish which of the two pieces of the function that you're using. So now we're going to drop our values in to all four and see what's going to happen. So in this equation, I will drop in negative infinity. So I'll want 1 over negative infinity minus 2. In this equation, I'm going to drop in 1 over 2 minus 2. In this one, I'm going to drop in 2 plus. 2 plus 1 over 2 plus. And in the last one, I'm going to drop in infinity plus 1 over infinity. Now I want to see what's going to happen with every single one of these. I'll slide this over a little bit. Something different is going to happen each time. Negative infinity minus 2 is still negative infinity. So I have 1 over negative infinity. That is not indeterminate. That is just dividing by the smallest number, or excuse me, the largest number possible. So the answer to that, I'm going to have to squeeze it in here, is the smallest number possible with a minus sign, with a left. Okay, not indeterminate. Okay, next. 1 over 2 minus 2 is 0 minus. That is not indeterminate either. That is 1 divided by the smallest number possible. Therefore, I get the largest number possible with a negative. For the next one, 2 plus 1 is 3 plus over 2 plus. That's 3 halves, 3 over 2 plus. That's just a constant number. And for the last one, I'll have infinity over infinity. So this is the only one of all four that was actually an indeterminate. And so I need to go back and divide by the highest value of x. So I'll continue this problem going back to my limit notation. And I will reduce, and I'll have 1 plus 1 over x over 1. Oh, you know what? Boy, I realized that back here. Wow, that was a long time ago that I made that mistake, that I wrote the fourth limit. You probably caught that already in your notes that I did that wrong. So let me fix that. That should be approaching infinity. Okay, now I'm going to drop in, because I already did the 2 plus. 1 plus 1 over infinity over 1. 1 over infinity is 0 plus. So 1 plus over 1, or 1 plus. So what does all of that mean? Because I got 4 different results. Approaching negative infinity, and I got that, means I have a horizontal asymptote at 0. Approaching positive infinity, getting this number, means I have another horizontal asymptote at 1. Approaching 2 minus and getting negative infinity means I have a vertical asymptote at 2 minus. And then plugging in 2 plus and actually getting a number, that just means I have a point. at 2 3/2. So each piece tells part of the story. So let's see if we could draw a graph that might fit that. When you are asked to draw a graph, I find it helpful to look at the limits that you're given and put them in numerical order. These are all mixed up, right? 2 minus, and then infinity, and then a negative infinity, and then -1, 2 plus. I feel like let's start with the one that should come first. And the one that should come first would be negative infinity. So I'm just going to reorder this. The limit as x, so it's like you number them, right? This is going to be number 1. After negative infinity, if I'm thinking in order, like from left to right, this would be number 2 because it's -1. And then I've got a 2 minus and a 2 plus. So the one that would come first would be on this one. That would be number 3. Then number 4. And then finally number 5. So I would think of them in order. And so I'm going to do the limit as x approaches -2 of f of x. And that equals -2. That means that I have a horizontal asymptote. The negative infinity means horizontal, and -2. So I'm going to have a horizontal asymptote at -2. The next one, number 2, is the limit, that's this one right here, as x approaches -1 of f of x is 0. Those are two numbers, right? That's -1 and 0. That's just a number. So that means I'm going to have a point at -1, 0. So I'm going to put that on my graph. So I'm going to have an asymptote, touches really close, and then comes to that number. Let me put an arrow here. Number 3, the third one I want to think about. The limit as x approaches 2 from the left is infinity. That means I have a vertical asymptote. So at 2 left, so let's see. I have a vertical asymptote here. And it's positive infinity. So that means when I get close to this asymptote, I'm going up towards infinity with an arrow. Number 4, limit approaching to right. That's number 4 down here, that's negative infinity. That means another vertical asymptote, but this time I am down at negative infinity down here. And then the last one, limit as x approaches positive infinity of f of x equals 2. When you approach positive infinity and you get a number, that's another horizontal asymptote. So this one was horizontal. This one is also horizontal. This is vertical. This is vertical. Look at where the infinities are, right? Can you tell? If the infinities are here in the x approaching, that'll make a horizontal asymptote. If the infinities end up after the answer sign, that'll be a vertical asymptote. So my last one, and if neither are infinity, it's just a point. My last one is a horizontal asymptote at 2. So I've got another horizontal better do that in yellow. Okay, got a horizontal asymptote out here at 2. So my graph is going to get close to that asymptote, but not touch it. So that's a possible graph, okay, for this function that meets all of their requirements, but I find it's helpful to put them in order and think of them left to right. The last thing is just what you can and can't do with limits. It's the same thing that we could do before. You can add limits and you can subtract limits. That's legal. Okay, adding and subtracting limits is legal. You can multiply limits. That's called the product rule. The constant rule, if you have a constant, you can pull that out in front of your limit. Constants only, not variables. Okay, for multiplication, you're allowed to pull the constants out. And quotient, you are allowed to divide as long as you don't have 0 in the denominator. So these are the properties for limits of what you can and can't do. So this is tough stuff. So come ready with your questions on Wednesday, and we'll spend a good amount of time diagnosing your questions. And then if this has been a hard week for you, please sign up on Friday and come see me so that we can just spend a little bit more time kind of putting all of this abstract math together. Okay, good luck with this, and I will see you Wednesday morning.